Convection. Have you ever noticed how heat rises from a hot surface, creating ripples in the air? This phenomenon, known as convection, is also present in fluids such as water, oil, and air. Convection occurs when there is a temperature difference between two regions of a fluid. The hotter region becomes less dense and rises, while the cooler region sinks. This creates a circular motion known as a convection current. Let's consider a pot of boiling water on a stove. As the water is heated, the molecules at the bottom of the pot gain energy and begin to move faster. This causes them to spread out, making the water less dense. The less dense water then rises to the top of the pot, while the cooler, denser water sinks to the bottom. This creates a convection current that circulates the water in the pot. This process is also important in weather patterns. The sun heats the Earth's surface, causing warm air to rise and cooler air to sink. This creates a cycle of warm and cool air, which leads to the formation of clouds and precipitation. Without convection, we would not have the weather patterns we see today. Convection is also used in many industrial processes. For example, in a radiator, hot water or steam circulates through a series of pipes, heating the surrounding air. This warm air rises and is replaced by cooler air, creating a convection current that heats the room. The concept of convection currents is not limited to fluids like water, oil, or air. In fact, the theory of general relativity suggests that spacetime fabric behaves like a fluid, with the presence of massive objects distorting the fabric and creating a gravitational field. So, is it possible that convection currents could exist in spacetime fabric? The answer is yes. Just as temperature differences create convection currents in fluids, variations in density or curvature of spacetime fabric could create similar currents. In fact, some scientists have proposed that the expansion of the universe itself could be driven by a type of convection current in the fabric of spacetime. The idea is that regions of spacetime with slightly higher density or curvature would generate more gravity, causing matter to accumulate and creating a pressure gradient that drives the flow of spacetime fabric. This flow could then lead to the expansion of the universe. However, the concept of convection currents in spacetime fabric is still largely theoretical and requires further study and observation. Nevertheless, it is an intriguing possibility that could help explain some of the mysteries of the universe, such as the accelerating expansion of the universe. In summary, just as fluids can have convection currents, spacetime fabric can also exhibit similar behavior. While the concept of convection currents in spacetime fabric is still largely theoretical, it is an exciting possibility that could help us better understand the nature of the universe.